Hi, good morning everyone. This is Jagdish, Assistant Professor of EC Department, SNS College of Technology, Coimbatore. Today, in our subject VLSI Testing Design for Testability, we are going to discuss about SoC Design Methodology. That is System on Chip Design Methodology. Come, let's get into the topic. So, what is System on Chip? That means in the name itself, you can able to understand that the single chip which has a whole system. That's called a system on chip. A system on chip is an integrated circuit, that is an IC, that integrates all components of the computer or the other electronic system into a single chip. It may contain digital, analog, mixed signal, and often radio frequency functions, all on a single chip substrate. A SoC design is a product creation process which starts at identifying the end user needs or system. So there are two systems. There is a hardware and the software. Aims at delivering a product with enough functional satisfaction to uh, overcome from the payment from the end user. So SoC is a collection of IPs. IP stands for intellectual property. It may be soft IP and hard IP. The design starts from the specification to fabrication through the integration of various IPs. So definition, that means integration of complete system onto a single chip. So you can see in this image, as I said in the previous slide, the complete system on a single IC is called a system on chip. So you could see reused blocks is there, semiconductor, microprocessor, DSP processor, and encryption, customer design, everything which is combined together and kept on the single chip, that is called a system on chip. So here, the system on chip is evaluated in three phases. The first phase, logic, that is a ROM and SRAM. And second phase, ROM, SRAM, PLL, AD, and DA. That is analog digital and digital to analog converter. And the third phase, we have PLL, AD, and DA, application specific analog. So this is the evaluation of SoC. Board to chip. So, is it possible to design 100 billion transistor SoC in 100 days? So, the board component is there, and so RAM, ROM is there, CPU, ASIC, and DSP, PLD, EA by MS, everything is there. So, that's a board component. So, is it is possible to combine everything in a single that is a board meet that is it is able to possible. So, that is represented over here. So SoC architecture. SoC architecture contains of memory, processor, embedded software, RTOS, that is a real-time operating system, DSP or special FU functional unit, OCP architecture, configurable hardware, and RF mixed signal JTAG interface peripherals. So these are all the these elements of or the contains in the SoC architecture. So when it comes to the hardware, the analog ADC, DAC, PLL, transmitter, receiver, RF, etc. will be available. For the digital processor, interface, accelerator, etc. will be available. The storage, SRAM, DRAM, flash, ROM, etc. It is available in the SoC. And for the software, OS and the application is there. So SoC device, as we have seen in the SoC architecture, there are several components we have seen. The same thing, it is mentioned like in the SoC device. That is like DRAM, ROM, DAC, ABD, RAM, flash, WP ROM, then third-party IP, RISC, and DSP core. Everything is there. So when we are designing the system on chip, the following parameters have to be considered. That means architecture strategy, design for test strategy, validation strategy, synthesis and backend strategy, integration strategy. And need for SoC. Why we need the SoC? That means complex applications. That is, semiconductor density increases 58% per year, but the design productivity increases 21% annually. Process technology allows it high performance, miniaturization, battery life, short market windows, cost sensitive. These are all the thing why we need the SoC. And the characteristics of SoC is very large transistor count on a single IC, mixed technologies on the same chip, digital memory, analog FPGA hardware and software, multiple clock frequencies, hierarchical design with embedded reusable IP. So the growth of the technology, see from digital cellular handset to now DVD player. So the DVD video player, LAN WAN, video games, wireless infrastructure to digital cellular handsets. So there is a abrupt growth took place in the SoC designs that you can see. So architecture strategy, there are following things. There is central processing core, DSP core, on-chip bus, easy plug and play IP, IBO peripherals, platform-based design methodology, parameterization, and function partition. Alternative computing system, controlled dominated systems, and data dominated systems. These are only two alternative computing. SoC complexity and abstraction. So the this is previous one, and today we can embed so many things in a single IC. So how to overcome the SoC complexity? Use a known real entity and partition modeling. These are all the methods to overcome the SoC complexities. Thank you.